Hello Year 6 and welcome to this flipped classroom session on place value. Now, as you will all know, our counting system has a series of symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we can make any number we wish using these symbols. Now, these symbols are referred to as either numerals or digits. Now, don't confuse Roman numerals with numerals, okay? So if a question asks you to write a number in numerals, it simply means using numbers, not Roman numerals, okay? If it wants Roman numerals, it will say Roman numerals. And the other term for these symbols are digits. So we have 10 digits. And with those 10 digits or numerals, we can make any number we like, as long as we place them in the right place. So as long as we give them the correct value. Okay, so here's a whole number, an integer, the number 5. Okay, so we've got the numeral 5. Now, with different positions, it has a different value. If we move it into this first column, into the ones column, then it's simply 5 units, 5 ones. Okay, it's got quite a small value. If, however, we move it into this column, then it's worth 5,000, but only if we fill the remaining spaces with zeros as placeholders. Because if we take away the grid, without those zeros, we would still just have a 5. But because of those zeros, they are so important to place that digit 5. Without those zeros, we would have 5. With those zeros, we've got 5,000. And you can see it's a massive difference between 5 and 5,000. So those zero space holders are really, really important. Here's another example. Again, we've got our numeral or digit 5. This time we're going to put it all the way over here to the left in the millions column. Now, whilst the grid is there, whilst the columns are in place, you can see that it's worth 5 million. But again, those space holders, those zeros are really, really important, because as soon as we take the grid away, then without the zeros, you would simply have 5 again. But with the zeros, you can see it's a much, much bigger number. It's worth 5 million. Okay, so I cannot emphasize enough the importance of zeros, even though they're worth nothing. Okay, so here's an example of another whole number, 25387. Now, I'm not sure how to read that one, so I'm going to place it into the grid. There we go, 25387. And now we can use the column headings to help us understand the value of each of the digits. And if we understand the value of each digit, then we can read the number. Okay, now I can see on this side, I've got 387. My bigger numbers, I've got 2 10,000s, so I've got 20,000, and I have got 5,000. Now I could say 20,000, 5,000, 387, but it does sound a little bit strange. So what we do is we group together the digits that are in the thousands section of the number. So here we've got 25. So we've got 25,387. So we lump these two values together, the 10,000s and the thousands, to give us 25,387. Here's a bigger number. Again, 536871. Without a little bit of help, I'm not sure how to read that. So I'm going to drop it into the grid. Okay. And again, I'm looking for the column headings. So I've got 500,000s, 3 10,000s, 6,000s, 800, 7 10s, so 70, and 1. Okay. But again, I'm going to group together the thousand values. In this case, 536,871. Okay. So I've still got my 500,000, my 3 10,000s, my 30,000s, and my 6,000s. But this time I've lumped them together to give me 536,871. Okay. And finally, this one, This one involves a 0, which can sometimes confuse people. Again, as it is, I'm not sure, so I'm going to drop it into my grid to help me read the number. I've got 3 10,000s, 6 thousands, no hundreds, 7 tens, and 4 ones. So I'm going to lump my thousands together to give me 36,000, no hundreds, and 74. Now, I wouldn't actually say no hundreds. I would say 36,074. But the 0 is still important. It shows we've got no hundreds. Without the 0, then these 2 digits would move across and we'd have 3,674, which is a completely different number. So the 0 is important, but we don't say no hundreds. We would say 36,074. Okay. Right. So we've just done this one, but without a grid, there's another way we can help ourselves read numbers. And what we do, we start at the ones column and we count ones, tens, hundreds, and then we place a comma. That breaks up the hundreds, tens, and units from the thousands. So we can now look at this number and say 36,074. Okay, so the comma, it's not, we don't have to do it. Okay, it's not a rule. It is there to help us. Okay, so with or without the comma, it's still 36,074, but the comma just helps us break the number down and helps us to read it. Okay, so with this one, again, I'm going to take my hundreds, tens, and units, and I'm going to put a comma just in front of them, and that helps us to read these bigger numbers. So I've got 52,753. I've separated the thousands part of the number from the hundreds, tens, and units. Just helps me to read it. 52,753. Oh, a bigger one now. But the same rule, I'm going to group together my hundreds, tens, and ones. So I keep saying units, hundreds, tens, and ones, and then I'm going to put a comma just in front to separate the thousands. So this time I've got 120,658. Okay, and final one, again, hundreds, tens, and ones, a comma just in front, just to separate them off. And there we can see all the thousands. We've got 572,865. Okay, so all the numbers, all the way up to infinity, we can write using those 10 simple numerals, those 10 symbols. But where we place them is really, really important. Okay, never underestimate the value of a 0. Okay? And just take your time as you say, read the numbers. Commas can help. You don't have to use them if you're confident, but they do help us break up those bigger numbers. Okay, guys, good luck with the next few lessons as we work our way into millions and some really big numbers. Okay, we'll see you soon. Take care.